Good evening, dear students. This is Mrs. Suhir Zaki, and we are going to continue our science curriculum for second prep students second term. Let's start our lesson for today. Today, dear students, we will continue our learning in the fourth unit of our science curriculum. With the title of Physical Changes in the Atmosphere. Our first lesson in our fourth unit in our science curriculum is the effect of temperature and pressure on the climate. Now let's go to learn our lesson objectives. Our lesson objectives for our lesson today, and by the end of the lesson you will be able to differentiate between weather and climate, identify the elements of weather and climate. Also, by the end of our lesson you will be able to conclude the factors affecting air temperature, conclude the factor affecting atmospheric pressure, and you will be able to analyze a given set of data to explore the relationship between atmospheric pressure and elevation above sea level. To learn about the atmospheric pressure, we will start by doing this activity 1. And now we are going to recognize our materials and tools for this activity. The first material and tools, 2 identical inflated balloons of the same volume, a rod, a pin. Now we will start our activity by the first step. The first step, fix the rod in a horizontal position. This is the horizontal position of the rod in our experiment. The second step, hang the 2 balloons on the rod to form a balanced first class level. Let's remember together what is meant by first class level. We have studied the levels lessons, and in which we classified the levels into 3 classes. The first class level, the fulcrum, is located between the load and the effort. In the second class level, the load lies between the fulcrum and the effort. And in the third class level, the effort lies between the fulcrum and the load. So in our experiment we will hang the 2 balloons to resemble the first class level, in which the fulcrum, this is the fulcrum in our experiment, lies between the 2 balloons, which represent the load and the effort, and the balanced first class level, in which the effort arm times the effort equals the load arm times the load. So we will have this first class level in a balanced position like here in our figure. Now, after fixing the 2 balloons in this position, what do you observe when one of the balloon is pierced with the sharp pin? So we will pierce one of the balloon with the sharp pin and observe what will happen in this case. Our second activity, to learn about the atmospheric pressure, we will start by the materials and tools as usual. We will need a peeled boiled egg, a bottle, a piece of paper, and a matchstick. In our experiment, we will start by ignite the piece of paper, then put it in the bottle. So we'll start by ignite the paper and put it inside the bottle. Our second step, we will do it immediately and very fast. We will immediately place the peeled boiled egg on the mouth of the bottle to close it. So we will start it by ignite the piece of paper and drop it quickly in the empty bottle. Then immediately place the peeled boiled egg on the mouth of the bottle to close it. So does the egg slide into the bottle while the piece of paper is burning, or after the flame goes out? What will happen? What do you observe during the second step of our experiment? Based on activities 1 and 2, it's concluded that atmospheric air has weight. This is demonstrated by the tipping of the balanced lever when one of the two balloons is pierced. So the atmospheric air has weight, and this is observed clearly. When we pierce one of the balloon, we observed the tipping of the balanced lever when one of the two balloons is pierced. In our second activity, atmospheric air has pressure, which is demonstrated by the egg being pushed into the bottle. So when the paper burns inside the bottle, the air heats up and expands, so some air escapes out of the bottle. After the flame goes out, the air inside the bottle cools and contracts. This causes the pressure inside the bottle to become lower than the atmospheric pressure outside the bottle. The higher external atmospheric pressure pushes the egg into the bottle. This is what happened in our second activity. We can see it in this animation, how the egg falls down inside the bottle after burning the piece of paper inside it. And as we explained, when we burn the paper inside the bottle, the air heats up and expands, so some air escapes out of the bottle. After the flame goes out, the air inside the bottle cools and contracts. This causes the pressure inside the bottle to be less than the pressure outside the bottle, so the egg is pushed down inside the bottle. So during our second activity, and as the paper inside the bottle burns, the air temperature increases in the closed space. In this case, this causing the pressure to rise since the air volume remains constant. And so, once the flame goes out, the air inside cools rapidly, resulting in a lower pressure inside the bottle compared to the atmospheric pressure outside the bottle. This pressure difference pushes the egg into the bottle. So the atmospheric pressure is defined as the weight of air column with a cross-sectional area of 1 meter square and a height extending to the top of the atmosphere. So it's as we measure the atmospheric pressure from the surface of the earth till the end of the atmosphere, in a shape like a column of air starting more from the sea level and ends by the end of the atmosphere with a cross-sectional area of 1 meter square. Of course, the atmospheric pressure is measured using a mercury barometer. This is the shape of mercury barometer and it's used to measure the atmospheric pressure. Atmospheric pressure at sea level is called the normal atmospheric pressure. So when we measure the atmospheric pressure at sea level, it's called the normal atmospheric pressure. It's equivalent to the weight of a column of mercury. This is the column of mercury, 76 centimeter high, acting on a unit area which is 1 meter square. This is equal to 760 millimeter mercury or 1013.25 millibars. So the normal atmospheric pressure is the weight of a column of mercury 76 centimeter high acting on the unit area like here in the figure in the mercury barometer, and it's equal to 760 millimeter Hg. Hg means mercury, or 1013.25 millibars. This is the value of the normal atmospheric pressure. Now let's go to the mathematical understanding. Each 1 millibar equals 0.75 millimeters of mercury. So each 1 millibar, once again, equals 0.75 millimeter of mercury. So the pressure in millibars equals pressure in millimeter mercury divided 0.75. If we have the value of the atmospheric pressure in millibars and we want to converge this value into millimeter mercury, we divide by 0.75. What are the factors affecting the atmospheric pressure? There are several factors that affect the atmospheric pressure, including the altitude, which means the height above sea level, the temperature, this is the second factor, and the humidity. So there are three factors affecting the atmospheric pressure. These factors are the altitude, the temperature, and the humidity. At the first, we will discuss the first factor affecting the atmospheric pressure, which is the altitude or the height above sea level. From this table, which is only for clarification, we will study the change that takes place in atmospheric pressure according to the altitude above the sea level. We will observe as we go higher above the sea level, as the altitude increases, the height of the air column extending to the top of the atmosphere decreases, and so its weight acting on the unit area also decreases. Therefore, the atmospheric pressure decreases as shown in our table. So as we move up in our atmosphere and as the altitude increases from 1,000 to 5,000, we will observe the decreasing in the atmospheric pressure from 899.76 to 540.2. So the atmospheric pressure decreases as the altitude increases, and it's of course an inverse relationship between the altitude above sea level and the atmospheric pressure. Now let's go to the next factor, the second factor affecting the atmospheric pressure, which is the temperature. When the temperature of the Earth's surface rises, the air above it expands. This leads to a decrease in its density and therefore a decrease in atmospheric pressure. So it's vice versa. When the temperature of Earth's surface rises, the air expands and moves up, and so the atmospheric pressure decreases. So it's also an inverse relationship. As the temperature increases, the atmospheric pressure decreases. The third factor is the humidity, and humidity refers to the amount of water vapor present in the air, and its value varies from one place to another over the time. Absolute humidity is the actual mass of water vapor contained in a certain volume of atmospheric air, and it's measured in gram per meter cubed. So the absolute humidity is the actual mass of water vapor contained in a certain volume of atmospheric air, and this is the unit of measuring the humidity, which is gram per meter cubed. Relative humidity is the percentage of the actual amount of water vapor in the air, which is the absolute humidity. Absolute humidity, as we mentioned before, it is the actual amount of water vapor in the air. So the relative humidity is the percentage of the absolute humidity to the maximum amount of water vapor the same volume of air can hold at the same temperature. When humidity increases, atmospheric pressure decreases slightly because water vapor is less dense than dry air. So as the density in this case decreases, then the dry air, the atmospheric pressure also decreases. Now we will study an integration of our topic with biology. The spread of influenza increases during winter because cold air has low humidity. When indoor air is heated while absolute humidity remains unchanged, relative humidity decreases sharply. This leads to the rapid evaporation of respiratory droplets, allowing viruses to remain suspended in the air for longer periods. In addition, the evaporation of moisture from the mucous membranes of the nose and respiratory tract weakens their ability to trap and defend the virus or against the viral infection, causing the infection or the virus to infect the person and cause the influenza. Now choose the correct answer. Normal atmospheric pressure equal A 1013.25 millimeter mercury, B 760 millibar, C 1013.25 millibar, D 760 centimeter Hg or mercury. Our correct answer, of course, is C 1013.25 millibar. Choose the correct answer. What is the atmospheric pressure defined as? A. The speed at which wind moves across a unit area. B. The weight of air of a column of air with a cross-sectional area of 1 meter square extending to the top of the atmosphere. C. The total volume of water vapor present in 1 meter cubed of air. Of course, our correct answer will be B. Atmospheric pressure is the weight of air column with a cross-sectional area of 1 meter square extending to the top of the atmosphere. Choose the correct answer. Which instrument is used to measure atmospheric pressure? A. Thermometer. B. Hygrometer. C. Mercury barometer. D. Anemometer. Our device that is used to measure atmospheric pressure is, of course, mercury barometer. Our next question. The following figure shows a device placed at the base of a mountain once and at its peak another time. What is the name of this device and what is it used for? Number 2. Identify which figure, X or Y, represents the device when it's at the peak of the mountain. Explain your answer. Let's try to answer our question. Based on the image provided here, and for the first question in the first part in our question, what is the name of this device? Of course, this device, as we explained in our lesson, its name is the mercury barometer. So the name of the device is the mercury barometer. Now, what is the use of this device? We use this device to measure the atmospheric pressure. So this is the function of our device. It's used to measure the atmospheric pressure. The second part of our question is asking about identify which figure, X or Y, represents the device when it's at the peak of the mountain, and explain your answer. Our correct choice is X. Let's explain. Atmospheric pressure is caused by the weight of air column above a certain point. As you move from the base of a mountain to its peak, to its top, the height of the air column above you will decrease and air becomes less dense. This means that the atmospheric pressure decreases at higher altitudes. So, in our device, in the mercury barometer, the atmospheric pressure pushes down on the mercury in the piscine, which in turn supports the mercury column in the tube. Since there is less pressure at the peak and higher pressure at the base of the mountain, so in case of figure X, the mercury column is visibly lower. This is the height of mercury column in figure X, and this is the height of mercury column in figure Y. So there is less atmospheric pressure here in figure X. This means that in this case, figure X represents the device when it's at the top or at the peak of the mountain, while figure Y represents the device at the base of the mountain, as figure X represents the lower pressure found at a mountain peak. Me, Mrs. Suhair Zaki, was with you under the supervision of the Science Consultant Office of Ministry of Education. This is our live stream platform of Ministry of Education. See you next session, inshallah.